3.8, number 314. We have x on y plus 5x minus 7 equals negative 3/4 of y. And they give us the point 1, 2, which is on this curve. And we're supposed to find the equation of the tangent line at the indicated point. So to find the equation of the tangent line, we need the slope of the tangent line to this curve. At the given point. So to find the equation of the tangent line, again, we need slope of tangent line. Slope of tangent line means we need the derivative, dy dx specifically. Right? So we must find the derivative dy dx. So that means we want to apply the d dx operation to both sides of this equation. So d dx, x on y plus 5x minus 7 equals d dx of negative 3/4 of y. All right, so I have to watch out for this subtle little quotient rule here. When the derivative is applied to each of these three separately because of the sum difference rule, you will encounter this one first, and that is a quotient rule. So the derivative here will be bottom, right? Bottom has derivative of the top. I'll just go ahead and write it to make it clear from what the formula is doing. So bottom derivative of the top minus top times the derivative of the bottom. So we'll dy dx here. Again, the derivative of y with respect to x is this set of symbols, and that is the object of concern in the problem. I really want to find dy dx over bottom squared, y squared. When d dx comes in contact with 5x, it's just the regular derivative of 5 because there's no y variable sitting there. And then minus 7 is, of course, going to 0. And on the right-hand side, we'll have the derivative of this will, of course, just be negative 3/4 bypassed because of the constant multiple rule. And then d dx applies itself to here, giving us what we described a minute ago as this set of symbols. All right, so there's two locations in this equation. Now we have dy dx. I need to get them together. So let's start to simplify this a little bit and gather like terms. So I'm going to separate these two. I'll have y on y squared will be 1 on y minus x on y squared dy dx still together. And then we have plus 5 equals negative 3/4 of dy dx. I'm going to just move this one to the right-hand side. That way I only have to do one move here. I'll just take this over here. It really doesn't matter if you take this one over here and move the 1 on y and the plus 5 over here. It doesn't matter how you play it. As long as you get all the derivative terms here together on one side and everything else on the other side. So we should have 1 on y plus 5 equals negative 3/4 dy dx plus x on y squared dy dx. So now factor off dy dx, we'll have 1 on y plus 5 equals dy dx times negative 3/4 plus x on y squared. Now dividing off, we'll have dy dx solved for. So I'm just going to rewrite it with dy dx on the left-hand side. Should be 1 over y plus 5 over negative 3/4 plus x on y squared. If we give everything the same denominator of y squared, it would look more like this. Y on y squared plus 5y squared on y squared. Right? Given this y on y, so it has the correct denominator. So, and this one y squared on y squared have the correct denominator, and this one y squared on y squared as well. So I have negative 3y squared on 4y squared. And then we'll have plus, this just needs the 4 down here, I guess, 4x on 4y squared. Okay, it's true I don't have a 4 up here. I didn't get the denominators exactly the same. We could introduce the 4's right now. There's another way I was going to play it, but let's just go ahead and introduce the 4's here. So this will be a 4, and then this will be a 20. Let's write the 4 times here, maybe. 4 times that. All right. So to finish it off, we now cancel all these denominators, and we'll have 4y plus 20y squared over negative 3, a little bit here, 3y squared plus 4x. Okay, so there's our derivative. dy dx equals that. All right. If that's the case, I now want to know what dy dx is at xy equals, the point was 1, 2 apparently. So plugging that in, we'll have what? 4 times 2 plus 20 times 2 squared, negative 3 2 squared plus 4 times 1. Just plugging in all the x and y values. And now let's just simplify and see what we have. So we have here 4, and this is 80, 88. We have 88 over 4 minus 12 is negative 8. Is that correct? And so we'll have what? Negative 11, it looks like, if I'm not mistaken. So negative 11, there's our slope of our tangent line. So now we just need to get the tangent line itself, in the usual case. All right. Slope-intercept form, there's the slope, and we just need the intercept. But we know that 1, 2 is on this curve, on this line, so therefore we'll have 2 equals negative 11 times 1 plus unknown y-intercept. Negative 11 added to the other side will be what? 13. So b is 13, and we have our tangent line. Y equals negative 11x plus 13. There we go.